Hello, Integrated Math 1. Welcome to lesson 1.2.2b. We're on day 2 of dealing with our arithmetic and geometric sequences, and we're going to start looking for some more patterns within them. We've already established an arithmetic sequence is when you're adding a constant or subtracting a constant, and we refer to that constant as the common difference. We also established last time that the geometric sequence is if you are multiplying or dividing by a constant, typically multiplying by a constant, and we refer to that constant that we multiply by as the common ratio. And that's how these work. We're going to start looking for more patterns within those, though. Now that we know what they are, we're going to take it a bit further. So as always, you're going to want a calculator today. Definitely a helpful thing. I'm also going to recommend that you have some scissors handy and some glue stick, maybe tape. Those things will be very useful to you today. So just to get us started and get our brains going in the right direction, we have warm-up number 3 and 4 here today. You did 1 and 2 last time. We're doing number 3 and 4 today. And just like we've been doing all week, I'd like you to write the next 3 terms in each sequence, and I'd like you to explain how you generated each term. Go ahead and hit pause to work your way through these, and then hit play when you're ready to check your work. So I noticed with this particular sequence, 1, 5, 17, 53, 61, and 485, I was like, all right, well, it's definitely increasing. It took me a while. Did you have a hard time with number 3? I had a terrible time with number 3. At some point, I did realize, and it took me a while, I realized that I was multiplying by 3 and then adding 2. Yeah. So I had to multiply by 3 and then add 2. So 1 times 3 is 3 plus 2 is 5. And then I did it again. 5 times 3 is 15 plus 2 is 17. And then I was grabbing a calculator. 17 times 3 is 51 plus 2 is 53. So that was the pattern. That was a rough one. That was a very rough one. I totally agree. That was kind of mean. But that means for the next one, 485 times 3 add 2 means that the next term is going to be 1,457 times 3 add 2. I get 4,373. This is why you need a calculator. And then again, times 3 add 2, and I get 13,121. So yeah, I had to multiply by 3 and then add 2. I had a super hard time with this warm-up. You probably did too. Sorry. But hopefully you did a little better with the next one, 4, 10, 16, 22. And this one really wasn't bad at all. We were just adding 6 every time. So if I add 6 more, I get 28, add 6 more for 34, add 6 more for 40. So that one was manageable. Number 3, that was awful. Number 4, I was all right though. So yes, we're still continuing our discussion of arithmetic and geometric sequences. So again, we're going to be determining the next term in a sequence. We're going to recognize arithmetic and geometric sequences. We did a whole bunch of that last time. Add or subtract a constant, it's arithmetic. Multiply or divide by a constant, it's geometric. And of course, that constant when we add is our common difference, and that constant in a geometric sequence when we multiply is a common ratio. Today we're going to push a little further though. Today we're going to start looking at what happens when we graph arithmetic and geometric sequences, because something does happen. And we're going to start recognizing the graphical behavior of our sequences, increasing, decreasing, all that good stuff. And we'll be sorting our sequences graphically as well. So it's awesome. We've already talked about these key terms: arithmetic sequence, common difference, geometric sequence, common ratio. Again, these two go together, these two go together. It's kind of how it goes. And so again, we know that we're just representing patterns as sequences of numbers, and now we're just looking a little deeper at those relationships. And today we're really going to start digging in. What patterns appear when sequences are represented as graphs? Now, before we get to the graphs, you remember your sequences from last time, all your little squares, right? All your little sequences from last time. I'd like you to bust those out. We're actually going to glue them in today. All right. So they're not little random bits of paper roaming around in your poor workbook. So at the very back of this lesson, pages 117 to 127, there's a whole bunch of these pages. I want you to start working on these graphic organizers. All right. Please note there are 5 of them that say arithmetic sequence. Remember, we made a group of arithmetic sequences yesterday. There are 6 of these that say geometric sequence. Remember how we had a little stack that we made of our geometric sequences yesterday? Throw out the others. Yeah, I only want the arithmetic ones and the geometric ones. You can check the others out. And what you're going to do is you're going to glue in each one per page, all right? So for the arithmetic ones, we had 5 of those. You're just going to glue in 1 per page where it says sequence. Glue it in at the top, because underneath it, you're going to make a table. So go ahead and start by gluing in all of these. Again, make sure you glue your 5 arithmetic sequences onto the pages that say arithmetic and glue in your 6 geometric sequences onto the ones that say geometric. Go ahead and hit pause to glue those in. And again, push it toward the top because we're going to write below them. So make sure that you glue them in kind of toward the top so you can write underneath. Go ahead and hit pause to glue those in. Hit play to hear further directions. All right, hopefully by now you've got them all glued in so you can see I have my sequence glued in at the top. Now I don't have all of them up here, but I just have the one because I want to show you how this works. Note it says on each graphic organizer that you just put your sequences in, make a table underneath your numeric sequence. So if you remember back to the first lesson that we did in this unit, remember how we took our sequences and we made a table and we were like the term number, the term value. I want you to make a little mini table underneath it. Don't go into the other squares. We're going to be using those other squares for other things at later dates. But right now, just underneath this, can you make a table just like last time? You're going to do it for all 11 of these. Again, just a quick table. That's all you're doing. Term number and term value, just like in our very first lesson. Go ahead and hit pause, make your tables, hit play to keep going. So I made a lovely table here. My term number, 1, 2, 3, 4, 5, 6, 7, because I have 1, 2, 3, 4, 5, 6, 7 terms. This is a geometric sequence, by the way. You may have noticed sequence A is geometric, so that's why I'm on a geometric page. And then I just put the values over here, 45, 90, 180, 360, 720, 1,440, and 2,880. My table got it bled off a little bit. But hopefully your table is nice and neat and you can see it. So you've done that for all of your pages. You made a graph, you glued in your card, and you've put in a table. Now, let's talk about graphs, shall we? So as we've already discovered when studying functions, graphs can help you see trends of a sequence, right? Can help us see what's going on. I love the graphs. And at times, the graphs can help you predict the next term in the sequence. Very useful things. So here we go. Pages 113 to 115, it's just 2 pages. You have a whole bunch of graphs here. The graphs representing the arithmetic and geometric sequences from the previous activity are located on those pages. So what you're going to do first, cut out the graphs. Obviously, that's the first thing you need to do. Cut out all the graphs. Second, I want you to match each graph to its appropriate sequence and glue it into the graph section of the graphic organizer. Remember over here, there's a graph section. So I want you to figure out which graphs go with which sequences and glue them right next to them, okay? I find that using the table really helps me to match up my graphs. So I would recommend using those tables that you made earlier to help you match up your graphs. It'll just make things better and easier. So go ahead and hit pause, cut out your graphs, match them up with the appropriate sequence, use the tables, they help, and then go ahead and glue it into the graph section of the graphic organizer on those pages. Go ahead and hit pause, do all the work, it's a lot of work, and then hit play to keep going. All right, now I don't have room here for all of my little guys, so I'm just gonna go through. Are you ready? So graph 1 turned out it did match with sequence A. I don't think they're all gonna line up with that, but graph 1 does match up with sequence A. Sequence B matched up with graph 4. Sequence C matched up with graph 2. Sequence E matched up with graph 5. Sequence F matched up with graph 3. And notice I'm skipping a few letters. Remember, we threw a few out. Graph H matches up, sequence H matches up with graph 6. Sequence J matches up with graph 9, this guy over here. Sequence K matches up with graph 7, so that's this one right here. Sequence M matched up with graph 10, and that means sequence N, oh wait, we're almost there. Sequence N matched up with graph 8, and last but not least, sequence P matched up with graph 11. So if you need to hit pause, go and double check, make sure you got the right graphs with the right sequences, and that should make things a little better. Like I said, I found that using the table was super helpful. Maybe you didn't. I use the table for the sequences as X and Y coordinates to help me match up with the correct graph. For me personally, that was the easiest way to go. But now that you have all these graphs, because you have all these graphs, how can you use the graphs to verify that all of our sequences are functions? Do you remember we had a test? We had a test for graphs to determine whether or not they're functions. Go ahead and hit pause, write it down if you remember what that test was, and then hit play when you're ready to check your work. Do you remember what the test was? That's right. It was the vertical line test. So yeah, all of these graphs pass the vertical line test, which means all of these sequences, arithmetic, geometric, all these sequences, they're functions. Every single one of them is a function. I was looking at those graphs and I'm thinking about the fact that these are functions, and it seems to me that we might be able to sort them into function families. But you know what? We'll save that for next time. I hope you found this helpful. I hope you found this useful. If you have questions or concerns, email me, come talk to me, come see me during office hours. You know I'm around, and I'll see you guys later. Bye.